you are going to see the latest software for structural analysis and design of RCC framed structures using Cadmax software. You can download this software from the following link, that is in Google you search Cadmax freewares. You will see here my blogspot. In that, the first one is structural analysis, design and detailing of reinforced concrete framed structures. In that, the latest version is available in the last link. You download it from there. This file, the software contains only 4 files: 2 DLL files, 1 menu file, 1 drawing template file. To download it. So some antivirus is stopping this download SPS file. You click, because this one is the software developed by me only. There is no virus. Now it is downloaded in the name of cadmax.rar. Okay, I close everything. Then go to downloads. That cadmaxnet1.rar is the last downloaded one. So you extract from this file. For that, this extract to, you create one new folder in D drive. You create new drive, new folder, Cadmax 1, that is not available there. So it is a new drive, new folder, Cadmax 1. Then OK. Now this will be extracted to Cadmax 1 folder. Now go to the D drive, Cadmax 1 folder. You will see the following 4 files. So now we will start working in AutoCAD. You click on any AutoCAD icon. Click on File menu. Then create a new drawing. For template, you go to your new Cadmax 1 folder. In that, one DWT template file is there. You open it. This is same as AutoCAD DWT file only. Then this menu is available here, but this menu will not be available. So for that, I will unload that menu. Then I will create it for you. So your machine will be look like this only. So in that, I want to create a menu load. Type menu load in the command prompt. Then browse the Cadmax 1 folder where you have installed the software. Cadmax 1, cadmaxnet.mnu file is menu file. You open it, then load it. Now you will see cadmaxnet.1 menu is here. Now you close it. This is the menu, but it won't work now. So to make it work, we have to do something. That is, in tools menu, you click on options. Go to options. In that support file search bar, we have to add Cadmax for 1 folder. This will be your computer will look like this only. We have to add one, then browse G drive Cadmax 1, then OK. So Cadmax 1 is added to the support for search path folder. Next, you go to trusted locations. There will be nothing. We have to add browse same big drive Cadmax 1 folder where you installed your software. This warning will come. This is writable folder. You click continue. So then you apply it, then OK. Now the software is loaded. Now you click on load Cadmax. You see command netload cadmax1.dll netload assembly file name cadmax1.dll. It means the software is loaded. Now you can work with this software. So first I will draw one plan, that is some sample plan. I will write 1,1 at 6,0, then offset 6 meters. All dimensions are in meters. Then offset now I will insert this C block is available in the template file we have loaded. So I will give 0.45 by 0.45. Now array last rectangular, number of rows 3, number of columns 2, distance between rows 6, distance between column 6. Now I will dimension it. Decimal places I give as 2 decimal places, 6 meter. Then I will dimension this 6 meter. Continue 6 meters. Move just to keep it some distance. This is the center line sketch of the plan I just draw. Now I will array this in this direction also. Rectangular, number of rows 1, number of columns 3, distance between columns 6 meters. Okay. So this is the center line sketch of the plan. This is 6 meter, 6 meter, and this is also 6 meter by 6 meter. Now we will work with Cadmax software. This is drawn in 0 layer. Okay. Now I will go to 3-dimensional view, minus viewpoint 1, minus 1, 10. You can go by whatever method you want to 3 dimensions. In Cadmax net command, you give column command. So this dialog box will come. Column found elevation of bottom in meter, that is 0 meter, that is footing bottom. Then let us consider this as the some 6-story building. 6-story building with a floor height of 3.5 meters. So every 2 floors will get 7. So 3 into 7, 21 meters. Then basement height 1 to 1.5 meter. Then foundation depth or 2 meters. 2 meters. So 2.5 meter plus 21 meters. that is 23.5 meters. You give here 23.5 meters. This is rectangular column of size 450 by 450 mm. You give here, then click OK, and click on insertion point. Okay. So now you are going to copy this column only. If you want, you can draw in for the other place also. You will just array. Select object last. This is rectangular array. Number of rows 3 rows. Number of columns 4 columns. Distance between rows 6 meters. Distance between columns 6 meters. Okay, all columns are drawn. Now I will draw the grade beam, that is ground level beam. You click on beam command. This is a grade beam, so give a small difference. Erase that. Give beam command. Start point. You see this. You give as G beam layer 0, instead of 0 meter, you give foundation depth. It is 2 meters. Then this beam size is 300 by 500 mm. Okay, start point, end point supported. Okay, then that is okay. You will click on the start point, click on the end point. So grade beam is drawn at 2 meter level. Now you can array this. Number of rows 3, number of columns 3, distance between rows 6 meters, distance between columns 6 meters. So all are copied. Similarly, draw in y direction. Same conditions. Okay. Click on this. Then array. First. Rectangular, number of rows 2, number of columns 4, distance between rows 6 meters, distance between columns 6 meters. So all ground level beams are drawn. Now walls are going to be supported on these beams. So give wall command. Click on wall command. The wall command is going to rest on 2 meter, that is beam on support of the beam. This wall is ground level wall, so ground floor wall, G wall you give. G wall layer, then height of the wall is, that is our floor height is 3.5 meter, basement height plus 0.5 meter, 4 meter height. In that 4 meter, 0.5 meter is going to be reduced due to depth of the beam in the upper floors. So for that you give 3.5 meter as the height of the wall. In other floors it will be 3 meters only. Then you click on start point, end point. The wall is laid. You array this last. Rectangular, number of rows 3, number of columns also 3, distance between rows 6 meters, distance between columns 6 meters. Next wall, same along y direction. First, rectangular, number of rows 2, number of columns 4, distance between columns 6 meters, distance between rows 6 meters. Okay, so ground level walls also drawn. Now for first floor, I am going to copy beams from ground floor itself. So I will switch off all the layers except beam layer, that is G beam layer. I will keep it as the current layer. Then I create a new layer called beam. So already beam layer is there. Okay. So we need not create this beam layer. So delete this layer. delete layer. Okay, so beam layer is already there because already we have drawn one small beam in here. At that time this beam layer was created. So now you change this to G beam layer. This is properties layer. If you see G beam, you keep it as, change it to beam layer, then copy in the Z direction. Base point at 0, 4 meters. Then change the previous selection. Previous properties layer G beam, grade beam. Okay. Then you keep on column layer. Then set beam as current layer. Switch off the G beam layer. Now you are at the ground floor level, 4 level. Now you are going to draw the slab. Give slab command. This is if some values are there, you whatever maybe the FCK value, FI value, if you want you can correct. Now you can change any values you want to change the depth of the minimum depth of slab as 120 mm. You can change the clear cover to the reinforcement, main rods diameter and distributor diameters and spacing of rods, minimum spacing of rods. Everything you can change it. You can adopt the same values available here. Loads, live load, floor finish, light portion load, etc. Then click on OK. Now you click on the points. You click on 4 corners. Then here you see it is asking for slab number. This is the first slab, so I will give it as slab number 1. Then this is two-way slab, you give as T, two-way slab. Then elevation of corners are in same level. Yes, this is not a sloped slab. Then enter elevation of corners in meter. This is to 6 meters. Then boundary conditions. These are all 9 boundary conditions for two-way slab. Here in this situation, you give to adjust, continue, discontinue, that is 4. Okay, slab is drawn. Now you can array this slab. Number of rows 2, number of columns 3. This is 6 meters and 6 meters. Okay, the slab is drawn. Now you are going to draw the walls on the first floor. So give wall command. Here it is 6 meters. This is 6 meters, and also it is also not in G wall. It is in wall layer. The height is 3 meters. 3 meters 0.23. Okay. Then click on start point and then end point. Wall is drawn. Then array. Rectangular, number of rows 3, number of columns 3. Between rows 6 meters, column 6 meters. Okay. Similarly, draw wall in y direction. Then array. Rectangular, number of rows 2, number of columns 4. This is between rows 6 meters, in columns 6 meters. Okay, this is drawn. For further floors, we will copy it from the base drawing. So I will save this file as save as. You can save in any layer. Okay. Okay, I will keep it in this layer itself. This is sample model. Okay, sample model. Okay, I save it in the name of sample model. Now in this I will copy. I keep the column layer off, then wall layer also off. Beam and slab layers are to be copied for the further 6 floors. Okay, here this is in 6 meter level. We have to go for 23.5 meter level. So copy this point at 0, 0, 3.5 at 0, 0, 7 meter at 0, 0, 10.5 meters at 0, 0, 14 meters at 0, 0, 17.5 meters. Now 17.5 plus 6 meter will give 23.5 meters height of the column. That is okay. Okay. Then all the slab level layers are drawn. Similarly, I will copy the walls also. Now I will switch off the slab layer and beam layer. Wall layers I will copy. 3.5 at 0, 0, 7 at 0, 0, 10.5 at 0, 0, 14. So I think this will be enough. You switch on all the layers, okay, except 0 layer. Now all the layers are drawn. So for all the 6 floors, walls and slabs, beams, everything is drawn. So you save this at this level, sample model. Okay. Now what we are going to do is, now we are going to analyze this building using the Cadmax software. So in this, you give beam load command. Select the all objects. In this command, the loads from slabs and walls is transferred to beams. So the loads are transferred. Hereafter, this G wall layer, slab layer and wall layer are not necessary. Only the beam layer, grade beam, G beam layer and column layer are necessary. So this is the structure. So when once the beam color changes from green color to yellow color, it means it is loaded. Then you go for analyze command. Select all. So once the magenta color joints have appeared here, it means the analysis is over. Now you are going to do design work. Now D beam, design of beam. So M20 values of steel is 500, 500. Now I click a default values, clear cover to steel 25 mm, 8 mm diameter stirrups, 12 mm minimum diameter of main rods. Okay, I will select. Oh, all the design of beam is over. Next, design of column. Design for minimum extensity and design of cylinder columns. You click a this is FCK value and FI value. Minimum percentage as per IS code is 0.8%. Clear cover to steel is 25 mm. Okay. Design of columns is also over. Now design of footings. Isolated square footing, you click same FCK value, FV value, you give CSBC of soil as 250 kilonewton per meter square. Then you select all. So footings are drawn. You now go to the plan layer. plan view. Now we have to draw the grid lines. Grid line, you select objects, then enter 1 for ABC along y direction, enter 2 for ABC along x direction. We will go for 1. Option 1 you choose, then you select the first corner, you select the other corner. Okay. A, B, C, D, 1, 2, 3. So this column is A and 1 joining A1 column. This is A2 column. Similarly, B1 column, B2 column, etc. So now you are going to draw the detailed drawings. Detailing, you select foot to D. Select all the footings. Then pick the points. So footings will be grouped. Same size of footings will be grouped and put in a single. So that's all. So only 3 types of footings are enough for this. You see the sizes A1, A3, D1, D3, etc. are end corner columns. Then these are all intermediate columns. Then this is center columns. That is. Now I will draw one rectangle to show the column footing detailing in a separate sheet. Okay. Then I will do column detailing. For column detailing, I will switch off this foot layer. Then go for detailing. For that column detailing, you have to run cold diesel before column detailing. This shows how many floors and all. This 6 stories building. 0 to 6 meter is ground floor. Next 6 to plus 3.5, 9.5 is the first floor. Next 9.5 to 13. The second floor. Next 13 to 16.5 is the third floor. Next 16.5 to 20 is the fourth floor. Next 20 to 23.5 is the fifth floor. That is ground plus 5 floors. We put next full story data AutoCAD. Okay, then click on OK. Now you are going to do column detailing. Detailing column D. You select all the columns. Then enter start point for tabulation. So this is the column detailing. This is ground floor column, first floor column, second floor column, third floor column, fourth floor column, fifth floor columns. So here it is 22 numbers, 25 RTS rods. Column size is also revised for this the column, that is C2, B2 is that is innermost columns. Innermost column size also changed. That is 550 by 450. You can keep it as like this. For 22 numbers, 25 RTS, column detailing is not correctly drawn. We have to work out for this. Some manual corrections we have to do. Next, beam detailing. Beam D. Layer of this beam detailing is beam D. Then lower elevation of beam is 0. For all floor levels, we will do with 6 meter elevation. Okay. Then select objects. Along X direction, you select this one. Okay. Then pick a point to draw detailing. So the detailing is drawn. See this, these are all the grade beam level. This is 4 beam level. You can write text to indicate this is grade beam. This is 4 bar roof beams. Same will be used for along the 3 layer A3 to D3 also. So adopt same for A3 to D3. Thus both will be same type of loading. Now you can move this further to left side. Then beam D. You can give the commands in the command prompt also. Detailing beam D. Same. You select the central beams. This is more. This will be more loading than the previous one. You see the details. Mostly at ground level, same loading will be there. That is wall load only. When the floor level, both sides slabs are loaded. That is T beams like that. So rods will be something more. So this is the floor beam, grade beam. We can copy from this itself. Similarly, along y direction, you do beam D, same, OK, and select a point. This is also drawn. Let's see what is the values. Grade beam. This is L beam. Detailing is drawn there. And you can copy from the above. Row beam, row beam. Similar beams you can adopt the same. This is the along y direction interior frame. Here the rods will be something more than the previous one because both sides slabs are loaded. So this is the detailing for this. Adopt same for similar beams. Then we will draw slab detailing. For that we layer on, slab layer on, then we go for detailing slab D. You can go for 0 to slab D layer. Layer name is slab D. Here 0 to 6 meter elevation. OK. Then you select. Now slab detailing is drawn. You can see the 150 mm thickness and 10 mm 125 both sides. So this is the detailing of slabs. Now all design and detailing is drawn. Now we have to develop the design procedure. So for that You should switch off the slab layer and slab D layer. Now Cadmax net, you see, click on design procedure, beams 0 to 6 meter. If you give full elevation, all the beams design procedure will also come. Whatever you selected for detailing, you select here. So design procedure for the beams is completed. Then similarly column detailing, column design procedure. Design procedure, now you are going to draw the columns. Columns is 23.5 meters because column rods are curtailed each and every floor. So for that 0 to 23.5, okay. Then you can connect these four will be similar, right? Okay. Other things will be similar. So design procedure for columns is developed. To develop the design procedure for footing, click on Cadmax and design procedure, footings, okay. To select procedure for footings, you give command design procedure and then for select objects you select this 4, okay. For footings design procedure is also developed. We want to see the design procedure, so this will be in the drawing name with output name. Here it is in Cadmax new 2 folder we have developed. This is the sample model, that is the drawing name, dot out is the extension name. So this is our analysis of beams. So each and every beams, if you want you can manually also check it, check the values. Then lastly footing detail and design procedure, column design procedure, everything whatever we have done it is available there. So in this slab design procedure is missing, that is that we, before saving the drawing, that in the name of sample model the name was drawing 1 dot drawing 1 something like that. So for that, that will be available in the C prompt users MKSU app data local Autodesk AutoCAD 2016 R12 ENU, and then template, here it is available, drawing 1 dot out. It will be in the last, that is 6 meter by 6 meter. This we have to copy from here. Control C, then in the notepad we have to add it here in the top. Regarding the design procedure, some introduction may be there. There will be some text files I have already done. So from that, I will just copy from this and then edit it. Okay. Control C, then Control V. Here, construction of commercial building. It is load for taken as loads for commercial building loading. So commercial building, some place ground plus 5 floors. This building is 5 floors. Then this is 250 kilonewton per meter square or 2 meter depth. It's not by run by actually STAD Pro analysis also done, can also be done using this Cadmax software that I will present in this separate manual. Cadmax software only is used for all the things. So this is the design procedure. I will save it as, then I will close these things. Okay. So you can rename it as text file so that everybody can open it in any notepad. So in some computers out expansion cannot be opened. So the STAD model is also developed here in this std file. So how to analyze and design in STAD with interface in this Cadmax software I will explain later. So now you have almost completed everything. Design, detailing, analysis, everything is over. Now you can, for presentation, you can give certain layer of G-beam, layer of joint, layer of then slab layer. So this is for presentation. So you can give as rectangle, round rectangle. You can give it as center sketch with slab details. Then you can copy this. Then you can switch off the zero layer. Here you can delete the slab detailing, then switch on this and then we correct it as centerline sketch with the footing locations. That's all. You can now save this drawing. Now design procedure is also developed. The structural design and detailing is also done. This is the use of this Cadmax software. Okay, thank you very much. You also learned this software. This is available in freeware only. Okay, thank you.